Good afternoon, everyone. Where I stopped in the last class? Where I stopped in the last class? Anyone remember? Cardinality, modality is over. Are you there? Anyone is there? Anybody is there? Scenario-based modeling I discussed, right? Scenario-based means use case activity diagrams. Activity swimline diagram also discussed. Flow-oriented modeling. I don't remember whether I discussed this flow-oriented. Anyone respond? This I think this completed, right? DFT, data flow diagram symbols. Anyone? Anybody is there? Am I audible? Are you there? It's showing some participants in the participant list. Anybody is there in that? Sai Chand, Sheshu Kiran, 43, 45, 57, 60. Anybody is there? Am I audible? Anyone? Who is your MC? Who is your MC? Anybody is here? Sharath, Ankita, Madhvi, everyone login and they left. Lakshmi, Shiva, Sudha, what is this? Sai Chand, are you there? Sai Chand. Sai Chand is not there.
Hello, ma'am. Due to network issue, I can't reply. I couldn't.
I think I completed DFDs. DFD level 0, 1, 2 I completed. I don't know whether it's correct or not, but you people are not responding. So what there in my mind, I'm saying 0 level DFD for railway reservation and this level 2 DFD I completed. I think so. This is ATM level 0, level 1. I think I completed. If I did not complete, respond. Otherwise, I will continue with control flow model. means I completed. So control flow diagram means control flow means flow of control, not flow of data. Data flow we explain about flow of data. Flow of data we express first an overview. That is overview of the system is DFD0. Then when it comes to DFD1, this is DFD0. DFD0 is an overview of the system. Then when it comes to DFD1, what is DFD1? The internal details, how the entities are related each other through the process. So all the entities are connected through the processes only. We couldn't connect it to entities directly, and we couldn't connect it to storage unit directly. We need a process in between. The next is that I explained, I think. The next is level 3, level 2 means third level it is. In that, we could take a separate part. For example, here the sensor, how the alarm is generated after sensing smoke or based on the sensor status. So that part we are drawing using the DFD. This is what I explained in yesterday class. So next one, this is another one I explained yesterday. That was railway reservation system. In that one, what are the passenger activities are cancellation, reservation, and he can collect the ticket information. He can request for the ticket information, and railway reservation is the process, means that is a software, and admin is another entity. So how they are related to each other. And in level 1 DFT, I explained how the process is actually going on. That is explained in level 1 DFT. These two examples I explained in the yesterday class. So when it comes to ATM, ATM is another, this ATM DFD is given here. In that, ATM is the process. And what are the external entities? Customer keypad, control system. Database we should show in the form of storage unit. Storage unit symbol is not like this. This is entity symbol. That is wrong. So database you should represent in the form of this data store. Data store. One end should be off. But when we close that, it looks like an entity. Here you could see the reservation. These are the databases. So databases here we are representing the reservation, waiting table, generate report. All these are storage or databases. So we could represent in this one end open rectangular. So if it is a closed rectangular, means it represents an entity. So when it comes to ATM, we could see the database. This symbol is wrong. As I said, you should change this. Then coming to screen, printout dispenser and cash dispenser. These are the external entities. How they are connecting together. This is the level 0 DFT. When it comes to level 1, we are explaining in more detail. So that card reader, customer keypad, those same entities are given here. And you could see what are the internal process, account verification process there. So to verify the account, you need to send the PIN number and account number, and both will be verified. And if it is invalid, return the card to the card reader. If it is valid one, then display the customer option. He can recommend the operation, selection operation. Like if he want to withdraw the cash, he can withdraw it. If he want to transfer from an account to another account, he can do that. If you want to take simple printout, means you can take it. So multiple operations are available that that's why it's connected to the keypad. The customer can give the service option. Then after that, after the printout dispenser is there and cash dispenser is there. If you want to withdraw the cash, it will check the availability of the amount. If the amount is there in the account database, then we can take the amount and we can update the database and send the cash amount through the cash dispenser. So this is the level 1 DFT. Next is control flow model. Control flow means, so DFT means here we represent the data flow. Data flow model we used to represent using the entities, and in the last class I explained what are the symbols we are using according to Gaines-Sarson and Uden and Code. Gaines-Sarson, the process are represented in this way, data store in this way, and external entity in this way, data flow in this way. So when it comes to Uden and Code, it looks like this symbols. So you can either choose this or this. So you can choose any of this, but if you choose Gaines-Sarson, you should use all the symbols. You should not mix up. So this rules also explained in last class. When it comes to control flow diagram, control flow actually it's like a state chart diagram. State chart diagram, what is the flow of control from one state to another? When an event happens, how the system responds, from which state to state it's going on. So here, what are the states? Here, reset phase is there, state is there, ideal state is there, monitoring system status phase is there, acting alarm phase is there. This is based on the home security system. What was home security system? In the previous example, examples. Home security, safe home security system. Okay, this one is the data flow of the safe home security system, right? That is, what is safe home security system? Safe home means, let's try to explain, but nobody is responding. That's why I'm asking question and I'm answering the question. So whenever there is first, as a user, you can verify the status of the system. There is the obviously when you enter into one system, there will be a validation process. In validation process, it will check for the password and username. The verification process there. So that is the user command and data. So based on the verification, it can end either allowed to enter the system or else it is an invalid operation. So next, once the sensor is going to detect, what is sensor is doing? Sensor is a hardware part, right? It is detecting the status. What is the status? What is sensing? It's sensing whether the smoke, suppose if the smoke alarm is going to work, it's check for the smoke. Once it detected a smoke, what will happen? It will alarm it will make an alarm, or else it will at the same time it will send call to the number which is fed. Which number? Maybe a fire station number or to the owner number. So that is the whatever the current status is, it's displayed in the control panel display. So this is the home safe security system. That is, this is the simplest model. Okay, if you can add more features, more functionals, like if the theft control is not mentioned in the home security system, actually that also a part when we discuss all those options. So it may be somewhat complex, but here only explain about the fire alarm and its corresponding operations. So in the DFT, we explained how the password validation process going on and how the sensor is monitoring and responding to the fire or smoke. So when it comes to control diagram, these are the four states, right? In the first state, this is state. Because that's why we give the symbol of state. State usually represented in this form only. A curved rectangle. So reset means initial stage. So you are going to start the system, and if you may get some messages like please wait. Then you are going to start, means you push the button. Then system is going to start. System okay. Then what nothing is there to do. It's going to idle state. After that, it's going to ready state. After all the loading, software loading, it's going to ready status. Then once we activate it with our, once it's activated, what will happen is it's going to start monitor the system. How they are monitoring? They are checking whether is there any sensor is detected or not. So this process will happen, and once the sensor is triggered, since triggering, all these are control lines. It's because of when an event happens, it moves from one state to another state. So sensor is triggered, then it's going to take an action. What is the action? It's acting on alarm. So monitor and alarm. What is it? It's going to alarm means it will alarm the neighbors, and at the same time, it's going to take a call to the and notify the alarm responders. Alarm responders, if anybody is there, means who is the this alarm and the tab for phone call is going to send to some to the owner or to the fire station. Then if it gets some notification, it notify that response also. And all these states are moving, means the system is moving from one state to another state based on the input. What is the input here? A trigger or an event happens. So when an event happens, it moving from one state to another state. That's why we call it as control flow diagram. Here flow of control is explaining. So when you're going to create the control flow diagram, first you should list out all the sensors. How many sensors are there? We are using multiple sensors. Maybe in every single room we are using, or else we are using only in kitchen. Like that, we can list all the sensors that read by the software. So then list all the interrupts conditions. List out the interrupt conditions and list all switches that are actuated by an operator. Suppose if it happens, what are the switches operated, actuated? And list out the data conditions, whether it is empty, full or jammed. That also you have to list out. So these are the, to create a control flow model, first listing process, listing the sensor, listing interrupt condition, listing the switches, listing the data conditions. Then you can go for a review. In the review contain noun verb parts of processing narrative. So once you write the narrative, a power processing narrative, it will represent noun verb parsing. How is it possible? That I will show you the narrative. Okay, this is a narrative. Narrative explanation. In that one, you could see an audible alarm, a delay time, monitoring service, information, telephone connection. Here actually, we explained everything in the form of textual form, right? When a sensor event is recognized, software invoke an audible alarm attached to system. After delay time that's specified by homeowner during system configuration activities, the system dial telephone number of monitoring service provides information about the location, reporting the nature of event that has been detected, and the number will be redialed every 20 seconds until the telephone connection is obtained. All interaction form is managed by user interaction subsystem, which read the input provided through the keypad and function keys, displays, promoting messages and system status on the LCD displays. This is a descriptive description on SafeForm security system. Okay, first we have to list out in this way. Then from that, we could identify the noun and verb. What is the need of identifying noun and verb? For example, in the system, you could see the interact with user, configure the system, activate, deactivate the system, process password, monitor sensors, display message and status. So every process is a combination of noun, verb plus noun, right? So when the verb plus noun combination, interact is the verb, user is the noun, configure is a verb, system is noun, control panel, not control panel is an entity. Okay, it's this process. You just focus on process. Process is here in this process is a verb. Password is noun. Activate, deactivate are the verbs. This is a noun. So every single process is a combination of a verb and noun. So you have to list out that combination. Where is it? So control flow diagram. Yes. Then describe the behavior of the system by identifying the state. And then we can focus on the omissions. Omissions means is there any alternative way to reach it, or you can exit. I mean, for example, when there is a password validation, from we are giving the input password, but if it's not matching with the database which we are using, what will happen? It will show the invalid message, right? So that is the for omissions, means explicit conditions. So is it clear? Are you following me? How many of you are following me? Raise your hands. Manish Reddy, Saran, and Sathik Verma. These are the 3 people out of 39 students. So this is a proof how many of you are listening. How many of you are listening? Out of 30 students, 3 members are listening. This is the way people are attending the online classes. I have nothing to say. Then actually, I'm getting my point. Is there any doubt? Those questions are irrelevant. Many people are not listening. Why should I ask such type of questions? Don't know where we stopped, where I have to start. No connection. I'm handling multiple sessions. That's why I'm getting doubt. In your case, you are attending only my classes, right? For the subject. Still, you can't able to say, ma'am, we completed that till last semester. At least some students, they were always there to respond. I never got confusion on where I stopped because people will respond immediately. But this is what we have to ask 100 times, but still they are not all ready to respond. What question I'm asking, if I ask some questions from the textbook, will you answer? Will you able to answer that question? I'm asking whether are you attending the class, are you there, is it audible? These questions, anyone can answer, right? But still, actually, I'm doing my duty. I'm not happy, but still I'm doing my duty. The control flow diagram, this is the control flow diagram. Actually, I don't know how to teach you people. The students are not there, then to whom I am taking the class, I don't. If there is no audience, who will perform? The next control specification. Control specification means this is also another flow-oriented model. In flow-oriented control specification, we used to indicate how the software system behave when an event or control signal is sensed. For example, when it detects the smoke, it's going to do some actions, right? So this is the way how the software behave, which processes are invoked as a consequence of the occurrences of an event. So this is what we express in the in control specification. So we could say this is the behavior of the system. Behavior means it's dynamic. Sometimes the smoke may detect, sometimes it won't be there. So in both states, the system behave in two different ways. So state chart diagram is a sequential specification of this behavior. So we can call it as a state chart diagram. This one is also a state chart actually. It represents all the states and when a trigger happens or an event happens, how the system move from one state to another state. That is control specification. Then when it comes to process specification, we explain it in the form of a textual way, narrative textual narration. So it contains narrative text, program design language, mathematical equation, tables, activity diagrams. Okay, so this is a combination of all the process specification. For example, in a narrative text form, how could you represent? This is an example for a process password validation. How could you how could the system can validate the process? First is this password validation means you enter the password, right? So you enter the password through the keypad. Then it will display on the control panel, not the exact one. It uses some symbols, it replaces some symbols, but it is showing the. Then after saving the password, it may be 4-digit or 5-digit or 6-digit, whatever it is. Generally, 18 machines are taking 4-digit password, but other systems are taking different types of passwords. So any number of digit passwords it take from the user, and after that, what it will do, it will verify with the password in the database. Database may be master database is there, and primary and secondary database may be there. In master password, the owner and its not relative family members passwords, and in the secondary list may contain the relatives or cousins or maid, like somebody who's not directly contacting, directly not in that system. So once the family members, okay, husband, wife, and children is there, and parents are there, is all of these people, all of these people, password comes under master password directory. So once you enter the password, first it will verify with the master password directory. If it is not there, it will go for the secondary. So once it verified both are same, then only it will allow you to enter. So if there is no match, it's a invalid entry. So this is the way the password verification process is going on. So that we can represent. But when you write the password specification, process specification, you should mention the process name and ID. Otherwise, we couldn't identify which process it is, right? And you can give a description, a brief description if you want, you can give about the process. So this is the process specification format. You should not forget there should be a process number, there should be a process name. And the names which you used in the process should be logically related. Like whenever in the previous examples, whatever process you wrote, each and every select service, display customer option, verify PIN number, prepare printout. It's logically, you could, it's very related, right? What action you're going to perform, it's the same word you are using to identify it. So it's better to mention one process uh, in this way. And otherwise, what will happen, the others may not understand, right? Next is class-based modeling. Class-based modeling actually different types. Class-based modeling take use case and extract from it. What it extracts? Class, attributes, and operations. In lab, we already discussed about class diagram. Class diagram means we are explaining the relationship between different classes. Each and every class contains class name, class attributes, and its operations. So when you select the class, first you need to identify the analysis class. Analysis class, then specifying attribute and operations of that class, then CRC modeling and association dependencies means these are some relationships. So to draw one class diagram, first you need to identify the classes, then their relationships, and in the class you have to mention the class name, operations, and attributes. So this is the class-based modeling. How to then, when it comes to how to identify a class should be an external entity, a thing, occurrence, role, organizational unit, place, or structure. If any of these things, we can consider it as a class. So an external entity means anything which is external to the system. For example, here you could see in an ATM, keypad, customer keypad, control system, a screen, printout and cash dispenser, card reader, all are external entities. So, or a thing means any card reader is a thing. Okay. Okay, dispenser is a thing. So anything. Then an external entity thing, what we consider as a class, an external entity, thing, occurrence means any activity. For example, when a sensor event happens in a home security system, that event, the sensor event is an occurrence. So based on that, it will move from one state to another state. Then audible alarm is an external entity. So like that, you have to list out all the classes. So after that, after this classes, we can select potential class. Potential class means the classes which we selected through this methodology to identify it. By this, we identified this rules. No need to select no need to consider all those things. If there is no value for those classes, you need to consider those. So how can you remove some classes? So if a class which is retain some information, we should keep it as a potential class. Analysis class. So if there is a needed service, it's perform a needed service for that particular system, you can consider this as analysis mode. If it consider multiple attribute, also you can consider it as a analysis mode. If common attributes and operations are there, you can consider. Essential requirements are there, you can consider. Otherwise, then you have to include those potential classes in your analysis model. If it is not there, then you can remove these things. Remove those classes from your analysis model. If you include all the classes, then it's not complexity. You should include the relevant classes which support for the analysis. Is it clear? Is it clear? What is this? These experiments are all better. Responded to any questions. Anybody is there? Hello, anybody is there?
Yes, ma'am.
Preeti, yes, ma'am. Surya, yes, ma'am. 3 members are there in the class out of 8. I'm damn sure you people are not listening to the class. Just ask him what is. Someone should not, notice. It's not at this part where I stopped. At least you can respond that. This is the class selection criteria. So first you have to identify the potential classes. Potential classes means the classes which are comes under any of the category. Either it's an external entity or occurrence or a thing or or it's a part of an organizational unit. You can consider it as a potential class. Okay. So from the potential class, next step is you have to select the analysis model, means analysis class. At the time, you just remove the classes which is not relevant and it's not help you to do the design. So you can reduce some number of classes. So these are the main parameters you are considering while selecting the characteristics. The next is CRC modeling. Okay, this I'm going to end this after explaining. CRC means Class Responsibility Collaboration Card. What is it's a tool used to design object-oriented software. It's a tool for object-oriented software proposed by Ward Cunningham and Ben Kenbeck. Here we are using index cards. What is an index card? Okay, I will show you an index card. This is the form of an index card. It contains some details, means many cards contain some, each and every card contain some information. So when it comes for the formal meeting, like brainstorming sessions, what we will do in the CRC card or index card, we will write about what are the classes, what are the objects, and the responsibilities should be written on one side. Okay, when you write, you have to write the class on top. It's a responsibility you should write on the left side. And collaborator means this particular class is collaborating with some other classes. So other classes with which this class is collaborating to fill the responsibility, that is the collaborator. So you should mention like that. For example, this is an example for on the top, mention the class name, left side responsibility, right side collaborators. Like this, we should divide the CRC card into 3 CRC. See here, for example, student is the class name, means what are the responsibility of the student, means characteristics, student number, name, address, phone number, enroll in a seminar, drop a seminar, request transfer, whatever it is. The characteristics you have to write on the website. And collaborators,